Welcome back to the Nerdy Codes. In this video, you'll be learning about evolution of programming languages. As I said in the past video, I've just given the introduction to programming languages. In this video, you'll be seeing like what are programming languages and why programming languages evolved and which programming languages are used today. So, imagine you want to communicate with a person. You use English, Telugu, Hindi, Kannada, or any Bengali or any language you take, but any language you know. But if similarly, if you want to communicate with a computer, do you use these languages? No, right? You use programming languages. So, programming languages are something that are used to communicate with a computer. To communicate with a computer. So, these are called programming languages. So, over time, programming languages evolved to make programming easier, faster, and more efficient. So, first generation was machine language. So, what is the first generation? Like machine language. Machine language. What is machine language? So, machine language is something that is a native language of the computer. So, computer can understand only zeros and ones. So, you can only understand zeros and ones. So, example, we have an instruction 010101. Okay. So, this instruction had to be written only in the binary because computer understands only binary, that is zeros and ones. You cannot write addition, subtraction, or any human language, English, Hindi. You cannot. The computer does not understand it. So, if computer needs to understand, it should be given in the form of the instruction that is zeros and ones. So, what problems we faced during this is like it was very difficult to remember. Okay. And writing large programs was almost impossible using this binary. So finding errors was also difficult. So that's why programmers look for a better solution. If there is a problem, then we need to find a solution, right? So even programmers look for better solution. So then came a evolution of assembly language. So, assembly language came into the scenario. Assembly language was into around 1950s. So this basically replaced binary instructions with the symbols. So a binary language this machine language they were using only like binary like zeros and ones, right? Instructions were combination of zeros and ones that humans cannot remember, right? It was very difficult and it was very difficult to solve the errors also. So then assembly language was introduced. This replaced binary instructions with the symbols I say like addition, subtraction, multiplication, like add, sub, and then we have more. So we have many other assembly language like add, sub, mul, no, etc. So we have many others. So this instead of remember binary numbers like 0 and 1 that were very long. So 0 1 is basically very simple. We can remember. But there are many large instructions that were very complex to remember, very difficult for a human to remember. So this assembly language like add sub mul mo, this replaced this machine language. So this is very instead of this zeros and ones combination, this add sub mul mo like these instructions are very meaningful words, are very easy to remember, right, for a human being. So instead of remembering that binary numbers, so programmers could use this meaningful words. So and we have an assembler, so it basically converts the assembly language into the machine language. So because why this assembler is used? Because machine can understand only zeros and ones, right? It cannot understand even this assembly language. So an assembler is inverted. So basically this assembler converts this assembly language, add, sub, mul, and mo, and etc. We have many others. This is being converted into the machine language, that is into zeros and ones. So this assembler is basically software that converts this assembly language into the machine level language so that machine can understand. So, giving an example, instead of remembering a person's phone number, that is, you can save their name in your contacts, right? So, basically, you cannot remember everyone's phone number. So, that phone numbers are basically, you take it as a machine level language. So, but instead of remembering phone number, you save their name in your contacts, right? So, that is only the assembly language. So, take it as an example for that. So, even though assembly languages found like a solution for these machine level languages, even though scientists were not satisfied with this, scientists wanted a language that was closer to the human language. So, this led to the existence of high level languages. High level language came into the scenario. So high level languages came into scenario around 1960, guys. So 1940 machine language, 1950 assembly language, around 1960s high level languages. So what all programming languages you see now, like Java, Python, C, C++, every language is a high level language. So basically scientists wanted a language that was closer to human language so that human can easily understand it. So this led to the high level languages. So first high level language that came into the scenario was Fortran, guys. So Fortran is the first high level language that was introduced. Like it was used for mainly for scientific calculations and engineering applications. And then COBOL was introduced, and then Pascal. And I think many of you don't know these languages, but this was introduced first. And later, after all this, around 1972, around 1972, there came a famous language that all of you know, that is C language. So C language is a fundamental language. So it is a basic, right? All the languages that you're using today use the fundamental C language. So why C language was developed? Although Fortran and COBOL were useful, programmers wanted a language that could easily interact closely with the hardware. So this led to the development of the C language around 1972. So this was C language was introduced by Dennis Ritchie, famous scientist Dennis Ritchie. So it became the fundamental language and the mother of all the programming languages, because many modern languages are inspired by C only. Example like C++, Java, and we have many other languages like that were basically following C language. So why C was introduced at the time, and why it became very popular, because like it was a high level language and it is very easy to understand. And later it was like programs were divided into functions, guys. It was very fast to execute, and it could run efficiently also. So and the other point is like, now we can see about like C language is a platform dependent. So what is this platform dependent? So basically platform dependent is something that it can run on the same platform. So as I told you in the past video, what is platform? So platform is a place where we run all the applications, right? So example like a laptop. Example like a laptop. So in laptop, like I am using Windows. I'm using Windows. So I am using Windows of OS. Okay. Like my friend is using Linux OS. So my platform is different and her platform is different. So basically, the C languages used to run only on the same platform. Okay. If I develop a program, it could run only on the, like I have developed a program that can run only on the Windows OS. So it cannot run on the Linux OS. So it is basically dependent on the platform, guys. So C language was a platform dependent and object oriented. So basically it is a object oriented. Let me tell you what is this object oriented also. So basically, in the real world, everything can be considered as an object, right? Example, car, bike, me, human, stood, everyone, you, next phone, like whatever you're seeing around you, everything is an object. So in programming, so object means it is a real world identity. So class is a blueprint. So basically, C language is a high level language. It is a platform dependent and it is a object oriented. So these are the advantages of the C language. So if you write a C program on Windows and move it into a Linux, it cannot run. So it is a platform dependent. In 1970s, like the C language was introduced. And after this C language, around 1980s, there comes another famous language, that is C++. Even the C++ was a high level language, platform dependent and object oriented. Okay, it is a platform dependent, object oriented, high level language. So basically, even this was C++ language could only run on the same platform. It cannot run on the different platform. So this both C and C++ languages were both the platform dependent and and high level language. Sorry guys, to me I am mistaken. C language is a procedural oriented. So what is this procedural oriented and object oriented? So basically, procedural oriented means, like take an example of a calculator, right? Calculator is an one object. So it can run many functionalities. So we have a calculator. This consider it as an one object. Calculator can do many functionalities, right? Like addition, subtraction, multiplication, division. So it is basically C language is same. So it is a procedural oriented. So one object, many functionalities. But C++ like object oriented. So there are many objects and many functionalities. Like take example of a Zomato. Okay, Zomato, we have the in Zomato application we have user, we have the delivery boy, we have the hotel. So like restaurant where we have order from. So it is basically we have different objects, right? We have different objects and different functionalities. So that is about the object oriented. So this is the difference between the procedural oriented and the object oriented. So this is the difference between C and C++ language. But both are platform dependent languages, guys. Means they can run on the same platform. Like if it is developed in the Windows platform, Windows OS, it can run on the same Windows OS platform. It cannot run on the other OS like Linux and Mac or Android. In 80s, like C++ languages were introduced. In 1990s, there came a scenario like where in 1990s internet was introduced. So now you're using every application, like web application, like Instagram, WhatsApp, Facebook, every application you're using nowadays, it cannot run without internet, right? So internet changed everything. The scenario changed everything after the internet came into scenario. So internet was introduced around 1990s. So before internet, programs were mostly standalone applications. I'll tell you what standalone means, what are web applications. So after this internet, applications needed to communicate over the networks. So basically, we have LAN, we have WAN. So what is LAN and WAN? Local area network. For example, colleges, office buildings. So this is local area network, where computers are connected within a small area. And WAN, wide area network. That is example like internet, global company networks. Like computers are connected across the cities. Okay, that is across the cities and countries. That is our wide area network. So what problem we face during the internet growth is different organizations use different operating systems. Like if in a company, I'm in a working in a company, if I'm using the Windows OS, I can tell my friend or I can tell my company members to use the same Windows OS. But I cannot tell some company which is working in America to I cannot tell them to use the same Windows I'm use same platform I'm using, right? They can use their own platform, like they can use Linux or Android or Mac, anything. I cannot tell every company or cannot tell everyone in the world to use the same platform that I am using. So if I am using a Windows, like organization, like other organization or other company people might be using Unix. Other company people might be using Linux. So applications needed to run on all these systems. So basically, this created a major problem, that is portability. What is portability? Portability means like moving a program from one platform to another without rewriting the entire code. So if I am developing any application on like Windows OS, like I'm using Windows OS. So if I'm developing any application, it should run on every platform, irrespective of the OS. Like it should be able to run on the Linux OS, Mac OS, Android, any OS that is in existence. So it should be able to run in every OS platform. So that means it is in the meaning of the portability. So platform dependent languages are basically not they're not supporting the portability. Means platform dependent languages like C and C++, these languages can be run only on the same platforms. Means if it is developed on the Windows OS, it can be run on the same Windows OS. It cannot be run on the Linux or other OSs. But platform independent languages, they solve the problem of this portability. Like platform dependent languages, what they are faced. So these platform independent languages, when they came into the scenario, so this solved the problem of portability. Like they develop so use of this using this platform independent languages, we can develop the applications that are able to run on every platform, irrespective of the platform. They can run on Windows, Linux, OS, or Mac, Android, any platform, irrespectively. So these are what platform independent languages. So what are platform independent languages? I told you, right? So examples of platform independent languages are Java, Python, that we are using today. Why many companies are using this Java, Python is because of this, because it is a platform independent languages, irrespective of the OS you are using. In any country, in any like corner of the country, if you go, even if you are using one platform, if other person is using another platform, like any OS, like this Java, Python is used to develop applications that is able to run on every platform. So irrespective of this, like if it is Windows, or like if it is a Linux, it is developed on the Linux, it can run only on the Linux. No, not like that. If you have developed any application using this Java or Python, this platform independent languages, it is able to run on every platform. It is able to run on every OS. So this solve the problem of the portability, guys. As I told you, Java, Python are platform independent languages. Why Java became popular? Because it solved the portability problem. So Java introduced JVM, Java Virtual Machine. In the past video, I've told you, right, on the platform, you need to install again a software that is for Python Virtual Machine or Java Virtual Machine, like to run applications on Python or Java. So what is this process? Like basically you will be having the source code, and then later the compiler will convert this source code, and will be having the bytecode, and this later Java Virtual Machine will give you the output, because Java Virtual Machine exists on the different operating systems. So the same Java program runs everywhere. So Java, why it became so famous is because they have the slogan like write once, run everywhere. This becomes Java famous slogan. So write once, run everywhere. We have the slogan called WORA. So basically what is WORA? Write once, run everywhere. If you are developing one application in your system, it should be run on every system. So uh, like Java became popular like this. So now let me tell about standard applications and the web applications. As I told you, right? I'll tell you about standard applications and web applications. So what is standalone applications and web applications? Standard applications and web application. So basically standalone applications are developed using C languages, right? That is platform dependent languages. So basically, example, let me take about the calculator. So calculator, right? Calculator. So basically, calculator is a standard application. So what is a standard applications? An application, listen carefully, an application that is able to run with or without internet. So calculator you have in your desktop, right? So even if the internet is off, if even if the we don't have the data like internet, you can use the calculator, right? You cannot you can perform calculations in the calculator, right? Even if there is no internet, there is no data. So if, even if there is data, like even using this web like Google, you can search in the Google, and like you can search the calculator in the Google, and then you there also you can perform the like calculations in the calculator. So basically standard application is something, an application that can run with or without the help of the internet. With the help of the internet also you can run, or without internet also you can run. It's an application that can run with or without internet. So with or without internet. So basically, internet evolved around 1990s. So before 1990s, in around 1970s, the C language was introduced. At that time, we did not have any internet, right? So like a standard application, this calculator was developed using the C language, that is platform dependent language. So at that time we don't have internet, so they developed an application that would run without the internet. So basically, calculator is one of the standard application. So web applications, what is web applications? You can see in the name only we have web. So web applications are those applications that can run only with the help of the internet. They cannot run without the internet. So basically web applications are some applications that can run only with the help of the internet. With the help of the internet. Without internet, they cannot run. So now and all applications like Instagram, like you take WhatsApp, you take Facebook, any application without internet, they cannot perform, right? So these web applications can perform only with the help of the internet. So this is the difference between the standard applications. Standard applications like are built using this platform dependent languages like C languages, or that like basically they were able to build these applications before the internet. Now and all, like now in this scenario, now like in this era, like we will build all the web applications only, right? Like we have internet, so with the help of the internet we are developing all the web applications, that is using this platform independent languages like Java, Python. So we have these popular languages, so with the help of this internet we are developing these web applications. So this is about the standard and web applications. So now, so in I told you about all the evolution of the programming languages, and what is standard application, what is web application, what is platform dependent language, what are platform independent languages. So let me give you a fast summary. Okay. In 1940s, what came into the scenario? Machine language. So machine language was difficult to remember, difficult to understand by the humans. So then in 1950s, there came assembly language. That was quite easy to remember, right? I've gave you example, like you can easily remember the names instead of numbers. So assembly language came into the scenario. On even assembly language found to be difficult. Like you cannot remember all the names. So in 1960s, what came into the scenario? Like high level languages. The first high level language what? FORTRAN, and then COBOL, COBOL, and next Pascal. And then later, in 1960s only, I didn't told you, but in 1960s there is another language that came into the scenario. That is BCPL, guys. BCPL, and around like 19 end of the 1960s, that is around 1969 or 1970. 1970, there came the B language. So B language. Before C language, there came B language. And then in 1972, as I told you, C language was invented. And next in 1982, C++. C++ came into the scenario. And then in 1990, internet was introduced. And then after an internet it was introduced in 1995, this platform independent languages, that is Python, Java, from there from 1995 to 2010, like all these platform independent languages, that is Java and next Python, were introduced, and they became popular. They were already introduced, but they became popular around this 1995 to 2010, when came into the scenario. When internet was introduced in 1990, this Java, Python, like they became popular because they were platform independent languages. So they became popular around 1995 to 2010. So basically, programming languages evolved to solve problems, guys. But machine language solved communication. But assembly simplified this coding. But high level languages improved the productivity. So C improved the system programming. But C++ introduced the object orientation. So Java solved the problem of portability. So every new language that came into the scenario overcome the limitations of the previous languages. So whatever the new languages that came into the scenario, they solve the problem of the previous languages. So so this is the evolution of the programming languages. I hope you found this video helpful. So we'll meet in the next video, guys. Like, share, and comment my videos. Thank you.